Good morning. Hello.
Good morning, madam.
Yes, what about the others?
Good morning, ma'am.
Yes, today it's going to be a very important session. Okay, today we are going to cover the most important part. If you understand this single problem, what I'm going to take in today's class, then you can do any design problems of your asynchronous sequential circuit. In the previous class, we have seen about the analysis of asynchronous sequential circuit. In that, I told you all certain few small concepts on races and cycles, right? So the next topic, according to your syllabus, is actually with that single design example. So after covering this particular example, we can again go back to circuit with latches, see those circuits so that you will understand more easily. Then we can go into the next topic of hazards and then ASM. With that, the fourth unit will be over. So if today's class, I don't want any absentees in today's class, this particular topic is very important, but it is very easy. It is a bit long, but it is very easy. You'll have to understand every step what I'm explaining. Fine. Shall we start? Hello.
Yes, ma'am.
Yeah, please be little fast in replying in today's class. Since I have to cover all the steps, I want you all to. I just want the answer from you all whether you all understand or not. If you all didn't understand, tell no. I can repeat. If you all understood, please tell yes so that I can proceed. Fine. So first I'm going to start with the design procedure. Okay. First we have to obtain a primitive flow table. Okay. Then we have to reduce the flow table. Then we will be assigning binary state variables and obtain the transition table. Then we will assign output values to dashes and obtain output maps. Simplify the excitation and output functions. Draw the logic diagram. So as from the first class, whenever I read the steps, you all will not understand anything. But now, since I have taken the analysis, can anyone say me what is a flow table? Do you all remember or not? What is a flow?
Only
Yes.
only one staple sheet in a row, madam.
Only one table. That is primitive flow table. Generally, what is a flow table made up of? Whether it will be having alphabets or binary values.
Alphabets, ma'am.
Very good.
Alphabets, madam.
Yeah. So a flow table, the difference between a transition table and the flow table is for each of the state variable, you'll be having alphabets. Only that difference. Okay. So now we are going to go into these 6 steps. Okay. To understand these 6 steps, I have taken a design problem. Okay. Just an design example. So this is my problem. Like this only you all will be getting design problems. First, you have to read the problem in order to understand the question. Similarly, what I told in your combinational circuit. So I'm going to read the question. Design a gated latch circuit, okay, with 2 inputs. That is, one input is G, and that is nothing but your gate, and D, that is your data, and one output Q. So you understood that in this particular design of the system, you're going to have 2 inputs D comma G and one output Q. Okay. Now they have given the condition. The gated latch is a memory element that accepts the value of D, okay, when G is equal to 1 and retains this value after G goes to 0. Okay. Once G is equal to 0, a change in D does not change the value of the output Q. I'm reading it once again. Till this, you all have understood 2 inputs and 1 output is required. The second statement, what they are trying to say is they are trying to divide that gate, this gate element, as two different conditions. They are trying to say if G is equal to 1, what happens? And if G is equal to 0, what happens? So what they are trying to say is if G is equal to 1, the latch will operate as a D latch. D means what? Whatever input you are giving, that will appear as your output. That is your concept of your D flip flop or D latch. Okay, that D is nothing but your delay. So the same thing it is going to happen. And if G is equal to 0, at that particular state, it is going to act as a memory state. So memory means what? They, irrespective of the change in the input, whatever change you occur, whatever change it occurs in the input, the output will not be disturbed. Okay, the output will not change dependent on the input. Memory means it will just, for how many hour clock pulse you are applying, it will just carry forward your stored input data. Any doubts in this question? First, you all understood the question?
Yes, ma'am. Madam,
Oh,
G is clock on, na madam.
no, G is not clock. G is one of your input. Two inputs.
Okay.
See, ma, one more thing you'll have to remember. I have told you about a concept of synchronous and asynchronous. And when I spoke about the difference, I told you all that asynchronous circuits are non-clocked circuits. Right? There I told they are clocked latches. Here I told non-clocked. So this is understood. If it comes under your sequential circuit also, it is understood that no need of separately giving your clock pulse as an external input. Okay, we'll be only interested in the two inputs. Fine.
Okay, ma'am.
Okay. Now, the most important thing is I'm going to go for one diagram now, which is not at all like what to say. Now, this diagram is not at all needed. Like you'll have to draw it in the exam or what. It is just like a rough work. Okay. But without that diagram, you all will get confused when you all have to form the primitive flow table. See, Arma, for any design problem, the main table what you have to draw is your primitive flow table. If you have not made any mistake in your primitive flow table, then your final answer will definitely be correct. But if there is a mistake in your primitive flow table, that is your first foremost step. So if you did any mistake there, then your entire design problem will be wrong. So in order to make our primitive flow table without any mistake, by reading the question, for my understanding, I am drawing this diagram. Okay, it is up to y'all. Y'all can just roughly also note it. Okay, I have made this diagram from the question, what I have understood. So now what I have understood is G is going to have two different values. So first G is going to be fixed to 1, and then the G is going to be fixed to 0. These are the first two conditions what I understood from the question. Now after that, we have another input value. So what is the another input value? D. It can either take 0 or it can either be 1. So what format I'm going to follow is, this is the format what I'm going to follow. DG slash output. For writing the states, I'm going to follow input bar output. So for that input, I'm putting D value first, G value, and then output. All these are my user end. For my user purpose, I'm doing this. Okay, this is not actually in your exact design procedure. This is for my understanding I am doing. So if you all also, for any design problem, if you all can jot out like this diagrams, then I guarantee you all will never do any mistakes. Okay, if mental calculations, sometimes it may lead to error. So if you all jot it down like this in a diagrammatic way from what you all understood from the question, then definitely you all will never make a mistake. Okay, this is just my suggestion for you all. So now D value, it can either be 0 or 1. Now you all tell me from the question, if G is equal to 1, what will be the output? If G is going to be equal to 1, what will be the output according to the question?
Whatever the D input is output, madam.
Excellent. So whatever D value will be, that will be followed as your output. So that only I have shown here. Now see here, D bar, how we are going to write the states is, It is nothing but dg slash output. So now in this condition, this g value is fixed to 1. So here I'm putting 1, and here also I'm putting it as 1. Okay. Now after that, what I'm trying to do is, this d can take the value of 0 or it can take the value of 1. Fine. This is g, this is d, and this is your output. So now what I'm doing, d can take the value of 0 or 1, and g is fixed to 1. At that time, as that boy told, your output will be following your d value. So for in this condition, the output is 0, and in this condition, it is being followed and it becomes 1. So now this particular state, okay, this particular state becomes as your A state, and this particular state becomes as your B state. Any doubts in this first column, what I have done? From the question only I have framed this. Any doubts in this? Please
No,
ask
ma'am.
me. Girls, are you all there?
Yes, ma'am.
Yeah, any doubts?
No, ma'am.
No. Shall I move to the next one?
Yes, ma'am.
Okay. Now if g value is fixed to 0, okay, now again I'll be having two conditions. That is, d can take either the value of 0 or 1. But one important thing is, we have to take it from this A and B state alone. So now I'm copy pasting this A state here. Okay, 0, 1, comma 0 is what I have obtained for A state. For that particular, for this particular, I'm going to apply this condition. Okay, what I'm going to apply is, g value is going to be fixed to 0. So see here, actually this is what, this is my d and this is my g. So now in both of the cases, this is my d and this is my g. So in both of the cases, you could find that g value is fixed to 0. Now can anyone say me, according to the question, if g value is fixed to 0, what was the condition given in the question?
The data
Previous
will
D value,
return.
madam. Previous D value. Memory where?
Excellent. It will act as a memory element. So now what we are going to do, so now gg is going to be 0 and d is going to take the value of 0 for this and 1 for this. So now what, as E said, it is going to act as a memory element. So for this entire condition, your output is fixed as this memory. So it is 0 and 0. What output here you got, so that will be followed here as well as here, since it is a memory element. Fine, ma?
Yes, ma'am.
Fine. So now I'm going to my this condition. So now you could, okay, so now I'm naming these two states. This is nothing but my C state and this is nothing but my D state. So the same thing I'm going to do it here, but the only difference what here is, D value is going to become as 1. Okay, and this I'm taking as B state. From B I have to obtain this. So this is my B state. Now what I am going to do, I am fix my g value as 0 and 0, and d value I'm going to take it as 1 and 0, and this output will be followed here. Fine, 1 comma 1. So now this state will become as E and this state will become as F. So I have found my all my states. What are the possible states? What are all the possible latching states? A, B, C, D, E, F. I all able to understand from the question how I am segregating my states and getting it. Like you all can do it in your mind, but that time you all will be making some errors in writing these states. If no doubts for anyone, I will proceed to the procedure. Shall I?
Yes, ma'am.
For everyone it is clear, like how to write A. Don't memorize. Definitely it is waste of memorizing. You all will definitely not get the same question. Now we are using D flip-flop. Suddenly if they are giving you toggle flip-flop, then you all have to do this separately and see. Then only nothing is going to be helpful. Only if you all understand the base of the concept, then only it will be easy for you all to do it. But if you all understand how I'm doing it, then it is very easy. So now everyone has understood how I'm doing A state, B state, C state, D state, E state, F state. Now I'm into the procedure. Now only I'm following actually that, what to say, I'm following my design procedure steps what I'm given. So this is the table. Actually, if you refer in your books, if you refer in your Morris Mano book, or if you all refer any PPTs, or if you all refer any of your YouTube videos, for this particular problem, directly they have given you this one. So what is actually needed is they would have done it in their mental calculation and they have obtained all these states. But what my suggestion is, always I teach my students to draw a diagram, a rough diagram like this. Whether you can draw it in your normal sheet also. It is not needed that you have to go to the rough diagram and draw. If you draw it and show it like this, even the evaluator who is correcting your paper will be in a position to identify where you have gone wrong. Okay, even that we can identify. So we can understand that you have understood the concept, but slightly you all have gone wrong in some particular point. So my request to all my students is you all just go for this one. Okay, directly don't come for that table. For any design problem of asynchronous circuit, you all just jot down like this in this manner. I'm not fixing this is going to be the manner. It is up to you. Okay, this can be roughly also noted down. I have done it so that you people will understand it very neatly, since this is your first design problem. Okay, now the same thing now I'm done the same thing. I'm putting state, inputs, outputs, DG and Q. So now we have found how many states were there. We have found 6 states. Okay, so now I'm writing it as A, B, C, D, E, F. So now how to write this here? Same thing I'm writing. So for A state, 0 1 0. See here, I have written that one. Sorry, 0 1 0. For B it is 111. For C it will be, see here, from here, C it will be 000. For D it will be 100. For E it will be 101. And for F it will be 001. Okay, I all clear with state, input and output? Yes or no?
Yes, ma'am.
Yeah. And this comments, you all may think it is waste of time. Definitely not. It is very, very helpful when you all are going to go for primitive flow table. So I will tell you all what is actually written in the comment. Now you all know if G is equal to 1, as that boy said, your delay, whatever input you're giving, that will become as your output, right? D input will become as your output. So when G is equal to 1, that is only going to happen. That only I have written. See here, if G is equal to 1, whatever D value you are giving, you are writing it as your output. Okay, that is my comment. Now, important thing comes after this. Now you could see that C state is also 0 0. F state is also 0 0. The input combinations for C state as well as for F state, it is 0 0. Then at that time you have to identify when the C state is coming, when this D state is occurring. So this is occurring after your A state. Okay, this is occurring after your A state, or else it might occur after your D state. Okay, this sentence I want to explain it with this diagram. Now see here, now they are telling, now this A state is there. Okay, now we are in particular C state. So this C state can occur only after this A state has occurred. Okay, only if this A state is available, you can go for this condition and obtain this state. So what I'm trying to say is this C state will occur only after this A state, or okay, otherwise this can be written here also. This can be your D and this can be interchanged here by just changing it. This as C and D, you can get it in the reverse way also. It is up to the designer, right? Some people, now another people, now suppose one person can take it this D value as 1, okay, and G value as 0 and put it here as 1. Okay, sorry, this is 0. So what I'm trying to say is it is up to the designer. This D value, it is not necessary that always you have to follow it as 0 and 1. Some designers can take it as 1 0 0 1, right? So now this D also can come forward. So only here they have put it as after state A or after state D. Now for this 1 0, now D state, okay, for D state, how you will get it? It is after state C, okay, and then for this E state, it is after state B or F, and F state, it is after state E. This is this diagram, this one, after state B or F, and this is F state, means after state E only you can obtain this F. Now you understood why I'm telling you to draw all this. If you draw all this, then writing this comments as well as writing this equations becomes very easy. Jotting down your inputs, output states will become very easy. Yes, any doubts in this? Even this you all should understand. Have you all understood these comments?
Yes, ma'am.
Everyone? Please tell fast so that I can proceed. Are you all there or not? This topic is very important. Please try to listen.
Yes, ma'am. Understood, ma'am.
Fine. So now, see, the next step is your, actually according to that design procedure, this is going to be my first step. Okay. But before going into the first step itself, you all need to complete these primary steps from the design question. So now I have just taken this as a reference because this will be useful for drawing the primitive flow table. So how you will draw the primitive flow table is like this. You have to jot down your inputs in your horizontal way, and all the possible states A, B, C, D, E, F, all this possible states should be jotted down here, and the input should be here. Okay, D and G. Now I will teach you all. This is very, very interesting as well as it is like a game. Okay, from this only I'm going to draw this. So now how I'm going to draw it. Now see here, first state. We are talking about your first state A. So now for this first state, what are the input combinations? 0, 1. So this is my 0, 1. And what is my output for that particular state? It is 0. So it is A. Okay, this is A. And the output is 0. So now why I'm putting this blue circle here? What it means?
Matches with the
Stable
input,
state,
ma'am.
madam.
Stable state.
Excellent, excellent. So now this is A is matching with this one. So this is actually going to represent my stable state. So now the necessity of your primitive flow table is that the adjacent values of that should be found. This is going, this particular box is your stable state, right? So the adjacent positions of that stable state should be found. So for these, the adjacent things are this box, that is 0, 0 and 1, 1. So now coming back to this table. Now 0, 0, this only I told you. Now this 0, 0, you are finding it in two positions. Am I right? You are finding it for state C as well as you are finding it for state F. But now at present, which state we are in? Now
Yeah.
at press A. Excellent. Now we are at A state. So now you see the comment. Now two combinations are present. So now we are going back to the comment after state A or D, and this is after state E. So now initially we are only in the state A. So we cannot think about E state. So the only possibility of taking is C. So I'm going to put it as, what is the output for that? And one important thing I
Can
want
be
to say
0 or
here.
1.
Yeah, no, it is actually 0 from this table. Okay, but why I'm putting this dash is one important thing. Keep it in your mind. Generally students will make mistake. Only for the stable states you should mention the output. You are writing this adjacent, no, for those adjacent things you should always put it as dash. Only you should put the state, and for output you should always mention it as dash for those adjacent elements. Fine. So now we have found the state as C, but we are not bothered because it is not a stable state. We are not bothered of the output. So I'm putting it as dash. Now coming to this one, I have to find for 1, 1. So in this table, I'm searching for 1, 1 combination. It is only B. So I'm directly putting it as B, comma, dash. Is this first row clear? And if no possibility is there, then you put it as dash, comma, dash. That's all. First row is clear for you all. Shall I proceed to B state now?
Yes,
Yes, madam.
Okay. Now, like B state, I will explain. From C state, you all will tell me the answer. Fine. So now for B state, what is the input in the table?
1, 1.
Yeah, 1, 1. So now I'm going to go to 1, 1 and I'm going to put it as B. Now this B is going to become as my stable state. So the corresponding output will be what?
1.
1.
One.
So this one, yeah, this one I'm jotting out here. Now after this, what is the next step? You have to find the adjacent elements. So now what are the adjacent elements? It is 0, 1. So in this I'm searching for 0, 1. I'm getting only one value and it is A. So for this, I'll not write the output. I'll just simply put it as a dash because it is not going to be my stable state. And what is 1 0? So if I'm going to see 1 0, now coming back again here, now you could see two combinations of 1 0. And what is, you have to come back to the comments. If you're finding two combinations, you have to come back to the comments. And this is after state C and this is after state B. This is only you have to use it. So the state is E. So now E comma dash. Second row, I all clear?
Yes, ma'am.
Yes, ma'am.
See, ma, the base fundamental of design is this table only. If you make any mistake in this table, if for a dash, if you put one also, it makes a big impact in your upcoming design. So only I'm explaining each and everything in minute details. Now coming to state C, now you all can tell me state C, what is the value? It is actually 0, 0. So the output is 0. I'm putting it here. Now after that, yeah, this is like a K map. I told this is not a fixed rigid structure. It is a folding structure. So now the adjacent element for this will be this one and the folded one, that is this one. Okay. So you have to find for this and as well as for this. So it is 0, 1. So if it is 0, 1, what will be the value? If it is 0, 1
A.
state, yeah,
A.
A comma
A.
dash. Yeah. And if it is 1, 0,
D and E both are there,
E.
ma'am.
yeah, D and E both are there. So you all will, now you all have to go and read
Will
the comments. Yeah, you will be
We'll
reading
mark it as
after
dash.
state C, after state B or C. So you will be putting it as after state C only is required. So you will be putting it as D. Right? A, B, C, all the three rows. Any doubts for anyone?
No, ma'am.
Okay.
No.
Shall we directly go to F state? I will explain you all because D and E is the same thing. Okay. Okay, now F state, it is going to be 0, 0. So I'm going to mark it as F comma 1. Okay, I'm going to find the adjacent elements. It is 0, 1. So 0, 1, I'm finding it in only one position. So A comma dash. And if it is this 1, 0 means 1, 0, it is going to come in two positions. But here it is after state F. So I'm going to use it as E comma dash. Any doubts for anyone? Why I'm putting that blue circle? Why I'm putting dash? Any doubts for anyone? So one important
Madam,
point. Yeah, tell me.
madam, for a state C,
Hmm.
adjacent D is there, ma'am. 1 0.
Hmm.
1 0 means D or E will come, na, madam.
Yeah.
D is after C only, na, madam.
Yes. So C state is over, no ma? C state is over. But here you can ask me why I'm not taking E. It can be after state B or after state F because F I am not come across. Suppose here if it is after state F na, this combination cannot be taken. So only I'm taking immediately after state C. That is safer side. No, that is C state would have completed. So I will take D.
Okay.
Yeah. Any other doubts? Okay. No doubt. So I want to just give you all one tip or hint. Generally, what people will do is like we will write the output for everything. Generally, what students will do is for all these dashes also they will write the output and keep, because in this column for all the combinations you are finding the output. So try to keep one thing. What I'm trying to say is only for the stable states the output should be noted down. The adjacent states the output should be mentioned only as dash. I will tell you all why. It will be useful in the upcoming slides. Fine. Now, I all clear with this table, primitive flow table.
Yes, ma'am.
Can anyone say me why this is called as a primitive flow table?
Ma'am, because in each row there is only one stable statement.
Yeah, very good. So, in each row, there is only one state, that is stable state. Okay. Yeah. Now, the next step. Okay. The next step is called as your implication table. So, what is this implication table? Is nothing but now you're having 6 states. Sorry. Yeah, 6 states we are having. From the diagram, so from the design, we obtained 6 stable states. Sorry, not stable states, 6 states are there. So, the use of this implication table is state reduction. We are going to reduce the number of states, okay, by obtaining a structure called as implication table. So now we can see that how I'm going to write this. I'm going to make use of this primitive flow table. I'm going to leave one state. A state I'm going to neglect, and in this horizontal manner I'm going to neglect my F state. One state on the top and one state at the bottom I'll be neglecting. You all may ask me why. Actually, this is a fixed format given for your implication table. Actually, when this topic of state reduction comes, there is actually two or more ways. Okay, one hot method and the row elimination method are there, but the most conveniently used method is your implication table. So we will go with that. Those two methods I will teach you all separately, not in this design problem. Fine. So now this is the structure of your implication table. What we are going to do is delete one of the state in top as well as delete one of the state at the bottom. Simple. Other than that, what we are going to do is we are going to do one comparison. How I'm going to do the comparison. So first, you inside what and all I have put, no tick mark, some alphabets I have written, all that will not be there. Initially, what you will have is you will have just these boxes. Okay, you will have A, B, C, D, E, and in this A will not be there. So B, C, D, E, F. That's all. Now I'm going to fill up this. How to fill it up? So first I'm going to compare my A state with B state. Okay, I'm going to do the comparison. A with B. This is my first comparison. I'm going to go. Now C with don't care, no problem. Don't care with don't care, no problem. Now this A and A, they are matched because they are same state, so no problem. 0 with don't care, no problem. B with B, they will be matched, and 1 with don't care, no problem. And E with don't care, no problem. Don't care with don't care, no problem. So actually, if you see the correlation between your A state and your B state, it is completely good, 100% correlated. So I am putting a tick. Did you all understand now? A to B, why I'm putting a tick? It is 100% correlated. There is no mismatch of your state. So I'm putting a tick mark. Now I'm coming to A comma C. So now when I'm coming to A comma C, I'm going to compare A row with your C state. So C and 0 and don't care, it is matching. A and A is matching. 0 and don't care matching. This is don't care, so no problem. This is also matching. So I'm putting 100% correlation tick mark. Now similarly for A and D. Now I will tell you for A comma E. That will be interesting. See here, A comma E, first thing itself, there is a clash. C comma F, right? C comma F I'm putting, and I will tell you all this significance. Why I'm putting a don't care. Okay, as of now, let it be an X. Okay, let it be a don't care. I will tell you all why I'm putting it. Okay, I can put it as 1 also. I can put it as C comma E. Okay, yeah, I can put it as 0 also, but I'm putting it as don't care. I will tell you all why it is later. So similarly, you have to do for all the boxes. Okay, all the boxes you have to do. Now, will you all do it, or I have to solve for each box and show you all? Shall we do only for this B comma C? Yes, I want your inputs. You all want me to do it for all the boxes, or is it fine for you all?
Fine, ma'am.
Fine. Okay. Now come here. Now this is nothing but C comma F, right? C comma F, it is actually a don't care. Sorry, not a don't care. It did not match. Now we will compare that C comma F. Now C comma F. Okay. C comma F here. First thing itself, it is not matching. So now then others are actually, again, they are having one clash with D comma E also. So what happens is that since this is an into, so this into only I'm following it here. It is not at all going to match. So I'm putting into here. But if suppose a tick mark comes here, then this will become as a tick mark. And this will be added to your compatible pairs. But since here itself it didn't match, so this is always in your into mark. Okay, into mark or don't care condition. So now all this are your don't care conditions. So from this table, I'm just interested only in the tick mark pairs, and those pairs are called as the compatible pairs. That only I told you, 100% correlated or 100% compatible with each other. In matrimonial website, you all will find the compatibility match, right? How much percent it is being matching your star sign with another star sign. Same thing here. So now these tick marks are actually 100% correlation. So now we'll be taking A comma B comma A comma C, A comma D, B comma E, B comma F, C comma D, and then E comma F. How many ticks are there? 1, 2, 3, 4, 5, 6, 7. So that many compatible pairs should be written. So 1, 2, 3, 4, 5, 6, 7. Are you all able to understand how I'm forming this compatible pairs? Please reply so that I can proceed.
Yes, ma'am.
No doubts, right, for anyone? If you all want me to explain this or this, you all tell me so that I will explain. Okay, I think no doubts, so no reply is coming. Yeah. The next step of your design procedure is called as a merger graph. Actually, what is this merger graph is? It is very, very simple. You just have to put a circle and you have to put how many states are there. In this particular in this particular problem, we are having 6 states. So I'm putting A, B, C, D, E, F. That many states I'm putting. Okay. No, now as of now that 1 2 is not required. So now that many states I will put, and this compatible pairs I'm going to jot it down with a line. So now see here A comma B. So I'm jotting this line A comma B, and then A comma C. See here I'm drawing this. Then A comma D. So I'm drawing this, and then B comma E I'm drawing this, and then B comma F I'm drawing this, and then C comma D I am drawing C comma D I'm drawing this line, and then E comma F I'm drawing this line. I will clear how I'm drawing the lines. Very, very simple actually. What combinations are here? First, merger graph means you have to put a circle. In the first question, how many states have been you have found out? That many states you have to jot down as dots. After that, using this compatible pairs, you have to draw the lines. Clear? Any doubts in drawing lines?
No, ma'am.
No. So
No, ma'am.
now, yeah, good. So now I'm going to find the closed path. Okay, closed path I'm going to find. Now you could see that there are actually, that is maximum closed path. Okay, now actually, you see here. Yeah, this is one of the closed path. This triangle I have put, no, this is one of the closed path, that is BEF, and another closed path is your ACD. Any other closed path you all can tell me? You can otherwise go as A, B, D also will be your another closed path. Okay, it is up to you all to decide. So I have gone to 2 closed triangles, that is nothing but your ACD and your BEF. So with that I'm touching all. Actually, the aim of this is you should be able to touch all your paths. So now with this I am touching all my 6 states, right? With these 2 triangles itself I am able to touch all my 3 states. Am I right? So now I'm reducing. Why I'm going for this merger graph is it is for my reduction. Even my implication table is for my reduction. So what I'm doing is I'm reducing the states A, C, D. This first triangle. Okay. In this I have mentioned the first triangle is B, E, F. I'm making it equivalent to my B state, and ACD I'm making it equivalent to my A state. Clear why we have done all these steps, why I have gone to implication and why I have gone to merger graph? I'm going to reduce my six states to 2 states. Clear? Please reply.
Yes, ma'am.
Any doubts for anyone? Why today no reply I'm getting? Any doubts for anyone?
No,
No. Okay, I'm proceeding. Okay, I've reduced my 6 states to 2 states. Okay, this is my aim. Now coming to reduction. Okay, now the reduced states are, we have obtained this. Now what I'm going to do is very simple, ma. I'm actually having two different combinations. So this is my primitive flow table. I'm going to segregate it as two tables and write it. So I have found that A, C, D, these three things I'm jotting out here, and then B, E, F, I'm writing it here. Very simple. I'm dividing the primitive table into these two states based upon my merger graph. Okay, nothing else I'm doing, no other things I'm doing here. So after that, I'm going to merge the states. How I'm going to merge the states is very interesting it is. Now listen here, you have to follow from this side to this side. Okay, now how I'm going to do that merging is, this is what I have obtained in this. I'm going to merge this graph into this one. How I'm doing is A, C, D. Now I'm going to combine these three in column wise. So for the input of 0, 0, all this column you compare. It is C, don't care, C, 0, C, don't care. So what I can write it as C, 0. And then I'm merging all this. It is A, 0. And then I'm merging all this. It is B, don't care. And then I'm merging all this D, 0. So this entire table, I'm shrinking it into a single row, and this is called as my state merging. Okay, state merging or reduction of primitive flow table. After that, this fully thing, I'm going to make it as a single row. So for this, it will be F, 1. Yes, you all can say along with me. This is A, don't care. And then this will be B,
E
1.
comma
And
1. E
this
comma
column
1.
will be E, 1. Yes, fine. So now, the next step, I'm going to do very simple thing. I'm going to reduce it. Wherever I'm finding this C or D, I'm going to replace it with A, and wherever I'm finding this E or F, I'm going to replace it with B. This table, I'm reducing it like this using this condition. Okay, so only I put the condition this side. So it is like C I'm finding means I'll put it as A. So now A, 0, A, 0, B will be B only. And here D means I'll replace it with A. And here F means I'll replace it with B, A, and then here I'll be replace B, and E will be replaced with B. Okay. And one more rule is there. Actually, this is going to be your reduced table. Okay, reduced, finalized table. 6 states we started, but finally we reduced it simply with 2 inputs and with 2 states. Now, what is the thing is, there is a rule. Now, you have to see that all your states, not only stable states, not only the circled one, all your states actually should have outputs. Okay, this is actually your state and this is your output. Am I right? So now this is having output, this having output. But here you could find there is no output. And here you could find there is no output. So to assign the output value for these states, there is a rule. What is the rule? If you are not having output for this, then you have to check for the adjacent elements. In your adjacent elements, if the output is 0 and 0, then here you will be putting the value as 0. If your adjacent element is 1 and 1, here you will assign it as 1. Okay. You may ask me a doubt whether if my adjacent elements are 0 and 1, then it will become as a don't care. Okay, if it is 1, 0, it will also become as a don't care. Fine. This is the rule for defining the output. Is it okay? This table is okay for you all?
Yes, madam.
Yeah. Now, can you all understand like why that primitive flow table is so important? I'm telling, if you all make a small mistake in that, till this step, you all will be using the same thing. So all your full entire problem will become as a mess. So only I told you all you have to give full concentration for that. Yes. Going to the next last final step, transition table and logic diagram. This is my last table. So I'm going here for state assignment. I am assigning my A state to take the value of 0 and B state to take the value of 1. Okay, A is equal to 0 and B is equal to 1. See here. Now, okay. Now this is very, very important. Please try to follow. Now this is nothing but your state variables, and this is nothing but your output. So from this table, from this particular table, I'm going to write both. Okay. Now this A value, what we have assigned, state assignment, A value, what I have assigned,
0,
0, and B value, what I have assigned,
1.
1. So now my first box will be, what it will be, 0 comma, don't bother about this output, don't bother about this output, only the state you have to bother. So it is 0 0 1 0. Okay, 1 0 1 1. See here, first table, 0 0 1 0 1 0 1 1. Fine. Hello.
Yes, ma'am.
Yes, ma'am.
Yeah, and now I am going for that normal K mapping. Okay, this K map I'm doing, I'm getting the expression. Now I'm going to find the output. Okay, output, how I will find, I will use the same table, and where, which value I will write. Here I had don't care condition, but I have found the value by using this rule. I have found the value as 0 and 1. So what will be the box value there? Tell me, for the first row, what it will be output?
0 0 0 0
Very good. And the second row?
1 1 1.
Excellent. So, why it is 0 here? Yeah, actually here it should be 1. So, it will be a, so you'll be getting it as y. Q is equal to y. Fine. Hello.
Ma'am, in first row
Fine.
that is 0.
One
No,
also
ma'am.
0 will become 0, madam. 1
First
Where,
row.
ma?
First row,
first
ma'am.
row, madam.
Yeah, here also 0. Yeah, good. So, here also 0. Fine.
Yes, ma'am.
Okay, from this logic diagram, I don't think so you all will have any doubts in drawing the logic diagram. So this is your entire step, ma. This is your complete design procedure. Now, one small thing I want to add up. If you are being asked to design a circuit with SR latch, this is going to be your last step. So what I'm going to do is I'm going to make use of this column, this output. This is your output table, no? Output transition table. I'm going to take that table and I'm going to job this with my SR flip-flop or SR latch, which I know already existing. So I'm going to take it as this is my small y. Okay, this is my small y, and inside what values we will be writing is your capital Y, that you all know. So I'm going to take the combinations as 0 0 and then 0 1, where and all. Now see here, it is 1 0. These combinations I'll be taking. Okay, so 0 0 0 1 1 0 1 1. So for that SR latch, you all know, if it is 0 0, it is 0, don't care. Excitation table of SR latch, if you all could remember, you all will be writing 0x 1 0 0 1 and don't care, don't care. This is for your SR latch. So now this, how I'm going to draw it as a table. This is very, very important, where students will make mistake. This is the K map for your S. So how you have to, with these two tables, how you're going to jot down this is, it is very simple. When small y is equal to 0 and capital Y is equal to 0, at that point you have to put it as 0x. So you have to put it as 0 here. This is your K map, and here you have to put it for your R. So it will be 0x. Now next combination, it will be for what? Where you have to put, here you have to put it as 0. Small y is equal to 0 and your capital Y is equal to 1. So at that point, where it will come, small 0 is equal to 1 and capital Y is equal to 1, this position. So it should be 1 0. See here, 1 0. Understood? So now small y is equal to 1 and capital Y is equal to 0. So small y is equal to 1, okay, and capital Y is equal to 0. So where it will be? Capital Y is equal to 0 means this position. So it should be 0 and 1. According to this table only I'm writing. And now it is 1 1. So small y is equal to 1 and capital Y is equal to 1. Now this position as well as this position. So what it should be don't care as well as don't care. So here don't care. Here they have mentioned it as don't care, and then here it is don't care. So this don't care you can rewrite it as 0 and 0. So now after that they will do the K map and you can obtain the equation as S is equal to dg and R is equal to d bar g. So this is nothing but your normal SR NAND latch, and this is the diagram where you're taking D and G. Okay, this is for your NAND, and this is nothing but D bar, and this is your G you're taking, and you're taking your SR flip flop. So this is the end of today's lecture. Did you all understand? This is your last and final step. This is actually one subtopic SR with design with latches. So for that you have to recollect your latch what to say your latch excitation table and your output table. Then you have to correlate it for two maps. You have to jot down, okay, and then you have to jot it 0x, and then it will be 0x. Now you could see for this combination x is equal to 0 as well as y is equal to 0. So for this it will be 0x, and for this it will be 0x. Okay, here it is y is equal to y is small 0 and capital 1. So 0 and capital 1 means 1 0. So it is 1 0. And here it is small y is equal to 0 and capital Y is equal to 0 0. So it is 0x. Are you all able to follow what I'm trying to say? Yes or no?
Ma'am, can you please explain once again this circuit with SR latch?
Yes. Okay. Now see here, ma. This table you have it. Okay. I will remove all this. Okay, now this outside is your small y and inside values what you have put is your capital Y, that you have understood from the previous example. So now this is your SR excitation table. Now what I'm telling is in this combination small y is equal to 0 and capital Y is equal to 0. So if you look at this table it is 0 and 0. So for your SK map it should be 0. So it is 0, and for your RK map it should be X. So for this particular combination, this particular box, it is 0 and 0. So it is 0 and X. Now coming to the second position, y is equal to 0 and capital Y is equal to 0. Don't look at all these input combinations. We are interested only in this small y and capital Y. So 0 and 0. So again it should be 0 as well as X. Second box, did you understand?
Yes, ma'am.
Okay, now third box, can you say me? 0 and 1. So for 0 and 1, it is what? What value you should put for X?
1 and 0.
Yeah, 1 and 0. Now tell me for the last one, it is 0 and 0.
0
So
and
it is
0.
0 and X, right? So now coming to the second row, it is 1 and 1. So for 1 and 1, it is don't care. Okay. Yeah, 1 and 1 only. No, it is actually.
This
Yeah.
side also it should be don't care now, ma'am.
Yes, man. Don't care, man. Don't care. Don't
Yeah,
care.
yeah,
Zero
yeah,
there.
yeah, 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 yeah. It should be don't care. Correct. So it should be don't care. So for the next column, it is actually what? It is one, right? So one means what you will be getting. It is one and one. So it will be again don't care and
Don't.
don't care,
Don't care.
right? Then the next combination, okay, fully it will be don't care, right? So now in the up column, I think we made a mistake because here it should be 0, but here I consider it as 1. So it will be 0 and 0 means here there also it will be don't care. 0 and 0 means it should be 0 here and X here. So this entire K map will be your don't care condition. So for mapping, you can do it as this, any two things you have to map in order to get that equation. So they have just mapped this is as 1. Fine. And for this part, they have taken this as 0 and you have made it as DG. Actually, how you are getting this is flip-flop conversions. When you all do for D flip-flop to SR flip-flop, this will be the equation. To in order to get that, they are mapping this don't care as 1 and this don't care as 0. Sorry, 1. For just for mapping purpose, that's all. In order to get this dg, because we know that s converted to d flip flop will be this equation, and this will be the this equation with gated latch. Yes, no doubts, right?
Ma'am, no doubt, ma'am.
So this is the important problem that you should remember. If time permits, if I complete hazards and all, I will try to solve your T flip flop also, if time permits. Otherwise, you all just go through. It will be in your textbook. You all just go through by yourself and tell me, okay, whether you all have any doubts in design of T flip flop.